Electricity. The key areas covered will be potential divider circuits. What we will do today is calculate missing values in potential divider circuits. The potential divider. Remember, when voltage divides, the biggest resistor will always take the biggest share of the voltage. A simple potential divider could look like this. We have two resistors and two labelled voltages, V1 and V2. Example 1. Calculate the potential difference across the 12 ohm resistor when the supply voltage is 12 volts. Step 1. Calculate the total resistance. For this, it's as simple as adding up our 24 ohms and our 12 ohms. So we have 36 ohms for our total resistance as it's in a series circuit. Step 2. Calculate the current through the resistors. To do this, we want to use Ohm's law, so V equals IR. And we know that when the resistors are in series, the current is the same through both, as current in a series circuit is the same everywhere. So our voltage here is 12 volts because we're using our total voltage. We've got our current, and we've got our total resistance. So our current is 12 over 36. Step 3. Calculate the potential difference across the 12 ohm resistor using Ohm's law. So using Ohm's law again, V2 equals I times R2. So V2 equals 12 over 36 times by our 12 ohms, and that gives us 4 volts. The values of V1 and V2 depend on R1 and R2, and let's check this, that V1 over V2 equals R1 over R2. So we can put in our values. 8 over 4 equals 24 over 12, and yes, this does work out as that gives us 2 equals 2. Example 2. Calculate the potential difference across AB. Step 1. Calculate the resistance of the parallel section, RP, and then find the total resistance of the circuit, RT. So to do the parallel section, we've got 1 over RP equals 1 over R1 plus 1 over R2. This is 1 over 2.2 plus 1 over 1. And in total that's 3.2 over 2.2. You can pop it into your calculator or you can manipulate fractions, whatever way works best for you. Flipping our fractions, we've got RP equals 2.2 over 3.2, and that is equal to 0.6875 kilo ohms. We don't want to round too early into the question as it will not give us precise enough values when we come to the end of the question. So we want to calculate the total resistance of the circuit now. So our total resistance is equal to that 1.7 kilo ohms plus our resistance in parallel that we just calculated. And that is 2.3875 kilo ohms. Step 2, calculate the current. So we've got Ohm's law, V equals IR. Our total voltage is 5 volts. We've got our current, and we're timesing it by our total resistance. So our current is 5 over 2.3875 kilo ohms. Again, we're just going to leave it like this, so our values are going to end up more accurate. Step 3, calculate the potential difference across AB. So our voltage across AB equals our current across AB, which equals our resistance across AB. Oh, not equals our resistance, multiplied by our resistance. However, we don't know our current across AB, so we're going to have to approach this in a slightly different way. The voltage across AB is the same as our voltage in parallel, which can be written as the current in parallel multiplied by the resistance in parallel. These values we do know. So our current in parallel, we've got the 5 over 2.3875k multiplied by our resistance in parallel, that was 0.6875k. And our final value is 1.4 volts from that. And remember, this is actually equal to our voltage across the 2.2 kilo ohm resistor as well. Example 3. A. What is the reading on the ammeter? We can see this is a series circuit, and so we know that the current is the same at all points. And on our lamp, we can see it's given the value of 3 amps, so we know the reading on the ammeter is also 3 amperes. Part B. Calculate the resistance of Ry when the lamp is operating correctly. For this, we want to use Ohm's law, so our Vy equals IRy. So we've got our current, we want to work out our resistance, but we don't have our voltage, so this is what we want to work out first. We can say our total voltage is equal to V1 plus V2 plus V3. This is our rule for voltage in a series circuit. Substituting some values, our total voltage is 36. V1, we can say that is our voltage across the Rx resistor. V2, we can say is the voltage across the Ry resistor. And, not an equal sign, and that's adding on our 12 volts. We can see that's the lamp just there. So 36 take 12, we've got 24 on our left. Vx can be rewritten as IRx plus our Vy, so that's what we want to work out. The IRx is 3 times by that 2, that comes from our diagram. So we have 24 equals 6 plus Vy. Rearranging that, we get Vy equals 18 volts. We can now use Ohm's law equation, so Vy equals IRy, 18 equals 3 times Ry, so our Ry equals 6 ohms. Example 4. A potential divider is used to provide an output voltage, VO, from a 10 volt supply as shown. A. The resistance of resistor X is 1.2 kilo ohms, and the output voltage required is 6 volts. Calculate the resistance of resistor Y. First of all, we want to find our current. So using Vx equals IRx, because these are the values that we know here. So our Vx is going to be 10, take away that 6 volts that was mentioned. We want to be working out our current, and Rx is given on the diagram, that's 1.2 kilo ohms. So I is 4 over 1,200. Next we can find our Y. So Vy equals IRy, again just using Ohm's law. We know our Vy, that's 6 volts given in the question. We've worked out our current, that's 4 over 1,200. And we want to work out our resistance over Y. So Ry is equal to 1,800, which is 1.8 kilo ohms. A load resistor Z is now connected across the output as shown. A load resistor is a resistor across which a voltage is required. B. Explain why the voltage across Z is less than 6 volts. When Z is placed in parallel with Y, the combined resistance of Y and Z is less than Y alone. Our output voltage is proportional to the resistance, so if R has decreased when Z is added, our output voltage must decrease as well. Therefore, it's less than this 6 volts. C. Calculate the voltage across resistor Z when its resistance is 4.7 kilo ohms. First, let's add the values to our diagram that we already know. In part A, we worked out the resistance of Y to be 1.8 kilo ohms, and just now we've been told that resistor Z is 4.7 kilo ohms. We also know that the voltage across resistor Z is going to be equal to the voltage across resistor Y because they're in parallel, and this is going to be equal to 10 volts take away our voltage at X. To help us work out these values, we want to work out the current in the circuit, and to do that we need the total resistance. So let's work out our total resistance first. 1 over our resistance in parallel is equal to 1 over our resistance at Y and our 1 over resistance at Z, which is 1 over 1.8 plus 1 over 4.7. This is equal to 6.5 over 8.46. Therefore, our resistance in parallel equals 8.46 over 6.5. Rounded, that is 1.3 kiloohms. Therefore, our total resistance is our 1.3 kiloohms added on to our 1.2 kiloohms from our resistor X. This is equal to 2.5 kiloohms. Let's use Ohm's law, Vt. So our total voltage is equal to our current times by our total resistance. We've got 10 equals I times by 2.5 kiloohms. So our current is equal to 0.004 amps. Now that we have our current, we can work out our voltage at X. That's equal to our current times our our resistance at X. So Vx equals 0.004 times by 1.2k, which is equal to 4.8 volts. Now our last step is our voltage at Z, and that's equal to our total voltage minus our voltage at X, so 10 take away 4.8, which gives us 5.2 volts. The next few examples have proven much more difficult than the ones we've just done for higher pupils. Example 5. Calculate the potential difference across AB. A crucial piece of information here is that the top branch of the circuit has no effect on the bottom branch, and vice versa. They are completely independent of each other. If we want to calculate the potential difference across AB, we want to first have the current to do this, so we can use our Ohm's law. V equals IR. Let's use our totals this time. So our total voltage equals our current times our total resistance. Our total voltage is 9 take 3. That's given on the diagram there. We want to work out our current, and our total resistance is equal to 6 plus 18. Remember, we're taking the branches independently, and we're just going to look at the bottom branch just now. So 6 plus 18 is 24 ohms. We can put that back into our Ohm's law, rearrange, and we get I equals 0.25 amps. Now we can use Ohm's law to calculate the potential difference across AB. So VAB equals I times RAB, which equals 0.25 times by 6, which is 1.5 volts. Example 6. A battery of EMF of 12 volts and negligible internal resistance is connected as shown in the circuit's opposite. A. Calculate the potential difference across the 5 kilo ohm resistor. If we want to calculate the potential difference across the 5 kilo ohm resistor, we first need to know the total resistance of the circuit in order to find out the current. So our total resistance, as it's a series circuit, is just our 3 plus our 5, which is equal to 8 kilo ohms. Using V equals IR for our totals, this is 12 equals I times 8 kilo ohms, and so our current is 0.0015 amps. Now that we have our current, we can use this to work out the voltage on the 5 kilo ohm resistor. This is equal to the current multiplied by the resistance of the 5 kilo ohm resistor. So 0.0015 times by 5,000, that gives us 7.5 volts. Part B. 2 further resistors and a variable resistor are added to the circuit as shown. Show by calculation that there is no current in the 10 kilo ohm resistor. If there's no current in the 10 kilo ohm resistor, then we know that the potential difference is 0 volts as well. So if the potential at X is equal to the potential at Y, let's look at these separately. The potential at X is the same as our potential difference across R2, and we know that 7.5 volts as we worked it out in the last part of the question. On Y, we first want to calculate the total resistance in order to work out the current, to then work out the voltage across R4, as this is our potential at Y. So our total resistance is 22.5 plus 37.5, which gives us 60 kilo ohms. Using V equals IR for our totals, that's 12 equals I times 60 kiloohms. So our current is 0.0002 amps. Now we can use Vy equals I times Ry, which is 0.002 times by 37.5 kiloohms, which is equal to 7.5 volts. And to find the potential difference between point X and point Y, we have to take away X from Y. So our 7.5 minus 7.5, we can see they're exactly the same, so our potential difference is going to be 0 volts. Therefore, there is no current in the 10 kiloohm resistor.